This tutorial describes named selections. In HyperChem, there's always the current selection. If we make a selection, then this is the current selection, and various operations operate on the current selection. However, at times it's desirable to name a selection, and other facets of HyperChem operate on specific name selections. So, for example, if we select a ring, we can go up and name that selection ring atoms. This selection has no particular meaning other than that it's saved, and so we can always recover that selection by going up and select and recovering that selection. We can remove that name selection if we want, or just recover it in that fashion. So we can remember selections like that. These may or may not be used for anything particular, or they may be used by your own scripts or something of that sort. In some situations, when we make a selection and name that selection, it has a particular meaning. Another tutorial describes point, line, and plane explicitly, but there are other name selections. They generally have capital letters to distinguish them from the normal name selections. These are primary name selections, or ones that have specific meaning. These are generic name selections. Reactant and product are used in helping to try and define a transition state that you'll see in description of finding transition states. Plot 1 and plot 2 are used in doing potential energy plots, either a plot in 2D or a plot in 3D, depending on whether you need both variables or only plot 1. Ghost atoms are used in ab initio and DFT calculations. Ghost atoms basically have basis functions on them, but no nucleus, and are sometimes useful in intermolecular forces, for example, or situations where you have basis set extension. That is, as you bring two atoms or two molecules together, the basis set on one atom is assisting the other atom, and sort of distorts the result. So there is the possibility of using ghost atoms in HyperChem. NMR atoms are the atoms that have nuclear spins on them for the for performing the calculations of NMR shielding and coupling, and the same with quantum atoms in the NMR program. There is the possibility of doing part of the molecule classically and part of it quantum mechanically, and quantum atoms distinguishes the quantum region in some contexts. It's not used universally everywhere from here, but particularly in the NMR program uses quantum atoms. So these are the name selections, and they can be recovered and used in other contexts. But they're if we were to name something as NMR atoms, and try and that would be permanently named that way, and we could, however, and it has an alias which is NMR-atoms, and we can remove that or recover that as we like. But those are name selections.